Hello to the coding session. Today we'll be developing our first module, which will be the encoder part. Basically, we are going to develop the core functions within it. And in the second lecture, we will be coding the module as is. Okay, so let's get in. First of all, we are here having a recap for the full process. So we will have a list of corpus or a list of sentences, and then we will apply some normalization upon them and apply tokenizations and building the vocab and encoding these tokens into IDs. And after this, we'll be padding to have them all with the same length. So let's get in step by step as we have discussed this pipeline earlier. This is the corpus. This will be the tokenizer will be doing for each sentence, will be breaking it down into tokens. And after this, we'll be giving each token an ID. And then we will be replacing each token with the number. And then we apply padding to have the same size. Okay, so let's start the notebook. First, you will have, you will see this notebook with as is. I will be passing through it before running. So first we have this corpus, then we have this helper method. First one is a clean of the sentence, to be taking an input, a string, and returning a list of normalized, it should be normalized words. Okay, not sentences, because it takes a sentence as input, and we will be applying stemming. Okay. After this, we have another method called the create vocab. It will take the corpus, okay, and we will be the list of string, okay, and it will be returning a dictionary, which will be having a token and giving it an ID. Okay, so the output will be a dictionary. Then the encoding will be taking the data in a normalized sentence, tokenized sentences, and then encode using the vocab to replace each token with an ID. And then the pad sequence method, which is the last one, that will be applied to make all the sentences, all the tokens in the same size. Okay, then here we'll be running it, that the tokens should be cleaning and tokenizing the corpus. Okay, so it should be returning this list of tokens, and then we will be having this vocabulary. We will be calling the create vocab here, and after the last thing will be the encoding, and after that will be the padding. So all of them will have the same size. We're adding a padding of 0, and this is a check that all of them having the same length. Okay, so let's start from the beginning. First, we have two packages, two libraries to use for stemming and lemmatization. So I will be using the portal stemmer. For example, if I need to apply stemming on anything, I can just tokenization. Okay, so it will be removing any extension, like anything. If it was also like organization, there's taken org. Okay, so take into consideration that the lemmatization, which will be, I use the WordNet lemmatizer. Like if I need to lemmatize, for example, carrying a word called carrying, so it will not be returning the tokenized version of it. But if I apply stemming on it, it will be care, which is the right token. So what is tokenization? What is the stemmer and lemmatizer do? They return the word into its root, okay, as we have discussed earlier. So it's a part of the pre-processing, but I'm just telling you how to use them. So what is the problem here? Like it needs the pose tagger to make it work. We need to add this position tagger, so in order to part of a speech tagging, in order to make the lemmatizer work, because as we have discussed, it needs a dictionary to apply such lemmatization to produce the root of the word in an elegant way. But in this tutorial, we'll be just using the stemmer and neglecting the lemmatizer for now, because it will need a lot of details which is not needed for this lecture. You can work on it if you need. You can apply lemmatization and then apply stemming, or make the stemming and lemmatization as optional. So you can choose from which if you want to within the create the module part. But let's get through the main method. So the clean method, the clean text is first should be taking an input as a sentence, okay, and returning, let's remove this another argument, and returning a list of normalized words, which will be this stemmed word, like the root tokens, okay. So should be applying here stem word or word in sentence, but the sentence will be a list of strings, so you need to split it, okay. So here, if for example you use this data, this first sentence here, I'm calling it, and I apply clean text upon it, so it will be returning the stemmed version of such list of tokens, okay. So it will be returning each list as a tokenized version, okay. Next task will be this create vocab method, which will be taking this data as a whole, like it will be should take this and returns a list of a dictionary, okay. So first we need to work on this step by step. So first we need to convert such a list of strings into a list of tokens, okay. So we need to apply for each, we need to loop for sentence in data, we need to clean such sentence, okay. For each sentence we apply this tokenization. So now this is the tokens and we have a list of tokens, but we will need, like this will be data normal, okay. So what is the next step is to create a vocab, okay. So we need to give each token an ID. So first we need to transform this multi-dimensional array into a single dimensional array. In that case, we will need some method called the chain from the iter tools. We gonna import it. I will import it again for you. Iter tools import chain. So what does the chain do? It takes this multi-dimension and it parse it in a way to convert it into a single dimension, as you can see here. So this multi-dimension matrix, let's remove this for now. This multi-dimension matrix have been flattened into this single dimension, okay. But we need in a non-duplicate, because sometimes this sequence and sequence are duplicated, so we into here and also into here. So we need to apply a unique tokens to give them each unique token an ID. So first we need to make it a set and then a list. As you can see, the length of the tokens have been changed, okay. So we can call it these tokens, and to give each token an ID, we will be just creating a dictionary like token ID for ID token in enumerate tokens. Okay, but we need to make it +2 because we will be adding the unknown token and the padding token before with the index of 0 and 1. So like we need to give such unknown as index 0 and padding. Let's make the padding as index 0 and the unknown as index 1. Okay, and this will be the vocab, and this will be also be so we need to append this dictionary to the main vocab. So we to append two dictionaries, like for example, if I need to make a simple dictionary here, for example, like dict enumerate range 5. Okay, so this is D1 and let's call some D2. Let's say make it from 4 to 10. So print D4 from 4 to 10. Okay, and we need to append these two dictionaries. So we'll be using this double star technique, D1 and double star D2. So this will be appending both, like if it is from 50, so it will be appending these two dictionaries, as you can see, like this. Okay, so this is to append two dictionaries. Okay, so we need to append this symbol dictionary. Let's call it vocab 1. We can append it to this vocab. Okay, so we can see this padding as 0 and unknown as 1. All right, so this will be the output. So let's copy paste all this stuff within this method and just return the vocab as the final result. Okay, I hope you understand this pretty well. So if I call create vocab and give it data, it should be returning this vocab. Okay, I can call it capital V to make it different. Okay, next task is to encode this data, and this is data normalized actually, so it is the list of normalized sentences. Fine, so we need to normalize this. First we need to have a list of normalized which will be tokenized the sentence, and then we will be returning a multidimensional array with the indices. Okay, this will be a sentence, let's call it for better naming, sentence normalized. This will be a single sentence, and then we'll be encoding this single sentence into its according into respective tokens. So for example, data of 0, after cleaning it, we need to replace each word within it with the dictionary. Okay, so for token in this, we need to get this ID or the integer, the numerical value corresponding to this. So called method here get token. Okay, so get will be fetching the dictionary and returning its corresponding value. But what if this text, this token is not within our dictionary, our vocab? Then we can add a default value of unknown, which is the default value is 1, because the unknown here is 1. So we can add this as the unknown. Okay, for example, if I added a token with crazy, but returning 1, but machine returning 5, because machine have an instance within our dictionary. Okay, so this is the main output of our text. So let's encode the token in such a way, and this will be, let us normalize. Sorry, all of this will be normalized, and the vocab will be replacing each v in this manner. Okay, so for example, this data node, if I encode the tokens and give it the first or second record, so it should be, okay, it needs a vocab. I should send it also the vocab to grab from it. And as you can see here, this is the token. Okay, token sentence into sequence of token, and this is the output of it as encoded version. So after this, we need to see how to make it in the same size. Each token should be the same size. So for example, if I have this data norm that I have created earlier, and this data norm I need to encode each sentence, normalized sentence, or normalized sentence in data norm, and also surely forget to send the vocab. Okay, so as you can see here, they are all have a different size. So I need all of them to have the 6 size or the same size. So we have a method within NumPy called nb.bad. It takes first an array, like I can give it, for example, 1, 2, 3. And then we will be having another tuple, which will be taking 2 entries. First entry, what will be adding before this list, and how many items will be added after this array. So for example, I don't need to add anything before this 1 to 3 list, so I need to add 0. And after it, I need to add 5. And the value will be a constant. So for example, here it added 5 zeros after this list. But I don't need to make it like this. I don't need to add 5. I need the final length of this list to be 5. So in that case, I need to subtract from 5 the length of this list, for example, -3. So it will be adding just 2 zeros, because this list has 3 items. So I hope you got this idea. So what we are going to do here is first to define a max length, because this will be our 5 in this example, for example. So first we need to add 6 sentence of tokens, as you can see here, encoded tokens. Okay, so we'll be apply padding for this input sequence, and don't add anything before, and subtract from the max length the length of this sequence that you are giving me as input. And of course, the mode will be constant. Okay. So let's see how it works if we have here this would be encoded version of the sentences. Let's call it E capital, and then we should send it, for example, E of 0. So E of 0 is having 5 items, so I need to give it a 10 as the final size. So it should be adding 5 another items as the padding. But what if I need to make it 3? So let's see what is the output of the bad nb.bad. It will be giving a value error that it can contain negative values. So what should I do here? I should add another functionalities. If max length is less than the length of the sentence, the sequence, then I should just truncate the length of the sequence and return the truncated version. Okay. Other than that, we'll be adding, but okay. So what if I have add here the same size? It will not be giving any error, but it will give an error if this length is less than of it. So if here I apply now 3, will apply truncation to this list. And after this, I should just convert this pad into list to make it all the same size. Okay. So now let's pad all the encoded tokens. So for encoded sentence in E, pad this sequence or sentence, and the max length will be 10. So it will be all having this 10, and what if the max length is, for example, 4? They will be all truncated to 4. Okay, so I hope you understand this lecture. In the next part, we'll be developing the module, which will be, I will be sharing it through the repo as well, so you can solve it on your own before watching the video. And if you need, you can watch, of course, a video and solve it step by step with me. So see you there, and goodbye. Thank you.